The diameter and altitude of a can in shape of right circular cylinder are measured as 4 cm and 6 cm respectively. The possible error in measurement of diameter and altitude is 0.1 cm. Find approximately the maximum possible error in values computed for the volume and lateral surface of the right circular can. Let us suppose d is the diameter of the can and h is its altitude. We have volume of right circular cylinder equals pi r square h, where r is the radius of the cylindrical can. Since we have the relation half of diameter is radius, we have r equals d by 2. Thus, we can rewrite volume of right circular cylinder as pi into d by 2 the whole square into h. Or we have volume V of right circular cylindrical can equals pi by 4 times d square h. If we wish to depend on concept of differential to find error in values while computing volume and lateral surface, we will have to find out first order partial derivatives of capital V with respect to independent variables d and h. We have dou V by dou d equals 2 pi dh divided by 4, taking first order partial derivative of v with respect to independent variable d, considering h as a constant. Similarly, we have dou v by dou h equals pi d square by 4, which is the first order partial derivative of v with respect to independent variable h, considering d as a constant. By differential formula, we have dv equals dou v by dou d into delta d plus dou v by dou h into delta h. We have already found dou v by dou d equals pi by 2 times dh and dou v by dou h equals pi by 4 times d square. Thus we obtain dv equals this expression. If you take pi by 4 common from outside both terms, we have RHS rewritten as pi by 4 times 2 times dh into delta d plus d square times delta h. We have error in measurement of values of diameter and altitude of the right circular cylindrical can is given by delta d equals 0.1 and delta h equals 0.1. That is, delta d equals delta h equals 0.1 centimeter as per the question. Also, it is given that diameter equals 4 cm and altitude equals 6 cm. Giving these particular values in this expression, we have dv equals pi by 4 times 2 into 4 into 0.1 plus 4 square into 0.1. Thus we obtain error in measurement while computing value of volume of right circular cylindrical can is 1.6 pi centimeter cube. Now we will evaluate error in value while computing lateral surface area of right circular cylindrical can. We have lateral surface area of right circular cylinder equals 2 times pi rh, where circumference equals 2 pi r and h is the altitude of the cylinder. Since we have 2 times r can be written as diameter d, we can rewrite lateral surface area as s equals pi dh. Since we will be using differential formula, ds equals dou v by dou d into delta d plus dou v by dou h into delta h. Now we will evaluate first order partial derivatives of s with respect to independent variables d and h. We have dou s by dou d equals pi times h and dou s by dou h equals pi times d. Thus we have total differential ds equals pi h into delta d plus pi d into delta h when you take pi common from out.